All right. Welcome everybody to Drone Harmony's webinar on the topic of terrain-aware planning. It's my pleasure to be here and to see such a nice crowd that has gathered on an evening in Europe and maybe morning in the US, wherever you are in the world. So thank you for taking the time out of your schedule. I'm David. I'm a VP product and co-founder at Drone Harmony. And in the next 30 to 45 minutes, I'd like to present to you some of our newest features related to terrain-aware planning in the Drone Harmony platform. I'm joined here by Janine, who is our marketing manager, who will help me with the webinar. And I really encourage you to participate actively in the webinar and ask questions. So if you have any questions, feel free to write them in the chat. We will be monitoring the questions, and in the end of the webinar, we will also answer most of the questions. The questions that we cannot answer, we will follow up on in an email. The webinar is recorded, so if you miss something, don't worry about it. We'll be able to review it in the video recording that we will make available shortly after the end of the webinar. So everything will be on our YouTube channel, and you'll be able to review any information that you've missed. So as I said, the topic of today's webinar is terrain-aware planning, and what are the learning goals for us for today? So in the first couple of minutes, we will just recap the workflow in Drone Harmony. I believe that many of you know the workflow, have some familiarity with the specifics of the Drone Harmony workflow, which is based on so-called scenes, but I will recap it for everybody and for those of you who are perhaps new to Drone Harmony. And the core of today's webinar will be a demonstration of the new terrain-aware features in the Drone Harmony web application. I will demonstrate it through both presenting all of the features and touching upon various use cases that you may be interested in terms of the markets to which these use cases are applicable. Towards the end of the presentation, I will say a few words about the outlook for this particular set of features and how they relate to the rest of the Drone Harmony platform. So just let's start. So I remind you that the Drone Harmony platform is a software suite that's composed of a web application, a mobile application in the cloud. The web application is basically your tool for planning missions for your drones. The mobile application is your operational tool in the field. It has a lot of mission planning capability as well, but primarily it's the flight execution tool. And we have the Drone Harmony Cloud that kind of connects everything together. It synchronizes states between the Drone Harmony web application and the Drone Harmony mobile application, and enables you to collaborate easily between the office and the field. So first off, let's kind of recap the planning workflow in Drone Harmony so that we're kind of all on the same page before we dive into the specifics of working with terrain in Drone Harmony. So let me switch over to the Drone Harmony web application. So I will be demonstrating everything today on the Drone Harmony web application. And towards the end of the presentation, I will touch upon some of the aspects that are important for executing the type of flights that we'll be speaking about today primarily. So Drone Harmony is a data capture platform, and it's based on a workflow that has two key steps or three key steps. Step number one is describing kind of the environment. This is a step in which we want to tell the application what is the set of assets or obstructions in the scene that are relevant for a flight. This can be the building we're inspecting and the buildings around it, any trees, any obstacles or obstructions or no-fly zones that are out there. So what you see here on the map is a simple example of such a state. We have some colorful overlays that represent such asset information. And we also have those dotted lines. And these are the lines that represent flight missions. And generating flight missions is the second stage of the workflow in Drone Harmony. You set up a scene, you generate flights, you save this to your cloud, and then you execute those flights in the field. So a short reminder, in Drone Harmony, we have not only map interface, but we also have 3D interface. And the 3D interface is kind of the key feature that enables us to work with more complex, more vertical type of infrastructure assets. And planning missions for these assets is enabled by the fact that we can plan such missions. So in this particular example, you see a bunch of buildings in Zurich, some flight missions that were generated for these buildings. So this is kind of in a very short form, the planning workflow. Stage number one, you generate these colorful polygons or a scene, you import it, you outline it. And stage number two, you generate flights automatically based on the drone harmony algorithms. So we will go into the details of this particular workflow, which is specific to terrain-aware flight planning today. So let's go back to the presentation. So now I would like to switch to the kind of core demonstration of today's webinar, and that's demonstrating the terrain-aware mission planning capabilities within the drone harmony web application. So for this, I will just switch over here to the map and start by loading a different site where we are performing already some terrain-aware mission planning. And I will start talking about the different aspects of what's particular to terrain-aware mission planning. And then as the webinar progresses, I'll start touching upon things like how do you import terrain into the application, where is the terrain stored, and so on and so forth. What happens if I don't have terrain information about the asset and environment that I'm interested in. So let's load a different inspection site here somewhere in Zurich. So I'll load site, and I'll switch over here to this particular site. So as you can see, we have, again, a drone harmony site. We have some overlays, we have some missions. So now it's the first step where we start entering the world of terrain-aware flight planning. And the main thing to know in the interface is that we have a third view now in Drone Harmony Web, which is called 3D DEM. So you switch to 3D DEM just as you switch between map and 3D scene. You just tap here on view type and go to 3D DEM. You will be allowed to switch to 3D DEM if you have terrain data, digital elevation model data about the environment in the area in which you're currently situated on the map. So let me switch over to 3D DEM. So as soon as I do that, the web application will start loading terrain data that is available in this particular location, that is loaded in this particular location. So as with 3D scene, you start seeing the 3D nature of the data behind the scenes. So you see that our overlays, our polygons are now overlaid nicely over a terrain. And this terrain, this is somewhere in Switzerland. And you see that we have, as usual in any drone harmony mission, we have a collection of flight plans, we have a collection of missions. And in this particular case, you see that we are quite in a mountainous area, and we have two types of surveys that we've defined here. One is kind of a mapping survey here on the right for part of this mountain slope, and we have a linear scan here for kind of a linear object in the scene. So a state for terrain-aware flight planning in drone harmony is very similar to a state where we have 3D building models or block models. It's a collection of, it's the data, it's terrain in this case, it's a collection of polygons or asset information like the polygons and the line, and it's a collection of missions. And we're able to work with terrain-aware flight planning in exactly the same way as with the same workflow as we do with any other type of flight planning in the Drone Harmony Web. So in this particular example, you will see that the terrain data that I have here, it actually extends far beyond where I'm doing my mission planning. And this is an aspect that I will touch upon later. How are we able to plan missions for terrain data that is really, really large? And in fact, the terrain data that I have here behind the scenes is the full terrain model of Switzerland. And our web application is powerful enough to be able to give you as kind of a seamless workflow with such large terrain data, because we kind of have a streaming service that was implemented to enable that. Okay, so now let's kind of step one step back and say, okay, how do we actually work with terrain? So there are two things that we need to say. We need to say how do we import terrain into the web application, and we need to say how do we plan flight missions for it. So actually, let's start from the latter because we already have terrain currently in the web application. So I'll switch over to 2D view. And what I'll try to do here now is I will plan a new mission. I'll plan a mission for this second area. I'll just plan a survey mission, nothing fancy, so that we all kind of understand how the workflow works. And then we will talk about the next step, which is importing flight missions. So as in every Drone Harmony mission, to start planning a mission, we go here to the plus. And in the plan catalog, we now have a new category. So previously in the plan catalog, we used to have mapping and inspection, all of these nice missions that you're familiar with, like top-down, double grid, and so on. We had a bunch of categories. Now we also have categories which represent the type of data that we use. So we can switch here over to the terrain tab. And under the terrain tab, we have a brand new collection of missions that we can use to plan terrain-aware flights for the terrain that we have in the scene. If terrain is not loaded, you will not have this option. It will be grayed out. But here, since I have terrain behind the scenes that I've loaded before, I have all these options. So let's just plan a simple terrain map flight here. So I pick the area I pick the mission that I want to plan. And the next step is, as usual, choose the area that I want to inspect with that particular type of mission. So I choose this new area here, continue. And as in all cases with terrain-aware, with flight planning, Drone Harmony Web, we go through this linear workflow. First stage, we give a takeoff and landing location for our mission. So let's say both takeoff and landing should be in this spot. And I press to continue. And we switch into this kind of dual interface, as we did in every other situation. On the left, we have parameters that we can populate. On the right, we have a view on the particular geometric information that's relevant. In this case, is the 3D DEM for which we're planning now a new mission. So I still need to populate one parameter before I get a mission. So let's populate the parameter here. So let's say 50 meters above the ground. So as soon as I populate the parameter, a computation starts in the background, and soon enough I will have here a mission for my terrain and for the area that I've selected. The rest of the workflow is very similar to other workflows in Drone Harmony. We have a few tabs here representing different types of parameters. Overlap is one, camera parameters, of course, what kind of drone we're going to be flying this with, and so on and so forth. Any change I make is immediately affecting the flight that I see, and I can navigate around it. I can take a look. I can see if this is exactly the flight that I'm expecting, that I'm wanting for this particular mission. As soon as I'm done, I click on save, and I give this mission a name. Let's call it new survey. New survey mission, and I save this mission. And this mission remains in my state, just as in any other flight plan. The same mission I can view in other views. So I can switch over to 3D view and take a look at this mission, and I can switch over to map view. Of course, since it's a terrain-aware flight that I designed for a particular terrain, the most useful interface is the terrain interface. But here in 2D map view, I have the same level of control over my mission as I have over any other mission in Drone Harmony. So this was kind of a very quick overview of how to plan missions for a terrain that's already loaded into the application. Now we can start asking ourselves certain questions about, okay, I have terrain already in the application. How can I load terrain? How can I import terrain to the application? So for this, we've implemented basically two different routes, which really depend on the type of workflow and on the type of data and the amount of data that you have for your terrain-aware missions. So one workflow is in the case that you have your own custom terrain data and you want to use the data that you collected, perhaps in a survey flight or a LiDAR mapping mission. You created a point cloud. You want to use it for terrain-aware flight planning. So what way do you have as a user of Drone Harmony to use this terrain within Drone Harmony Web? So let me clear the state here and show you how this is done. So first off, where do we even find information about the terrains that we currently have in the cloud? So for this, we go here on the left to the menu, and we have several forms of storage here. You remember we have site storage. This is the information about the inspection sites that we have. And now a new category has appeared, and this is terrain storage. Under terrain storage, we have several options how we can add terrain to our, let's say, Drone Harmony cloud or a Drone Harmony state in the web. We have the option to upload a file. We have an option to import through a API integration that Drone Harmony has implemented. I will explain how to use it and demonstrate it later. And we can load a terrain that's already existing in the cloud. Let's say we already imported the terrain and we want to load this terrain to the state. So let's start with the simplest, in case we already loaded, in case we already imported the terrain. So I can go here to load terrain. And what I see here is I see all the terrain files that I've already loaded into my state. So let's choose one of them. Let's choose the first one here. I'll load this terrain file. So this, as you can see, by loading a terrain file, you see that you get a new type of overlay in Drone Harmony Web. In this case, this is this gray rectangle. The gray rectangle represents kind of the bounding box, a simple box representing where you have terrain data for this particular terrain data file that you've loaded. So in this case, we have it in this geographic region that's represented by this gray rectangle. Let's take a look at the terrain data. It's always a good idea to look at the data before we start doing any sort of planning for it. So here I switch over to 3D DEM again. And you see that in this case, we have a very nice terrain data file that is the data that's underneath. And I have very much flexibility about how I can interact with it, how I can navigate it, and how I can look at different parts of this terrain. So this is a beautiful terrain from North Arizona that our partner, Rich Charpentier, has generated in a survey flight. And I would like to thank him for providing us with this file for this demonstration. So this is a part of the granite dells in North Arizona. And you see it's a very, very high density, high accuracy digital elevation model. In fact, the accuracy here is less than one foot, which means that in every step you have, in the step size, basically every less than 1 foot, you have 1 point of data in every dimension. So, so now we've looked at kind of the first way how we can add data into the Drone Harmony web scene. So if we already have terrain loaded, we can, into the cloud, we can load it in this way. So the next step is, what do we do if we don't yet have any terrain in the cloud? Let's say we just collected a new terrain file. We want to upload new terrain to the cloud. So for this, we have another option in the menu. So let's go back over here. And let's go to the option upload terrain file. So upload terrain file enables you to upload any terrain in any coordinate system in a GeoTIFF file format. So let's do such an upload. So I click on upload, and now I'm presented with the option to browse my computer for a file. And I want to give this file a name. So let's first find the file. So I browse my files, and here in this folder of files, let's choose this file here. It's kind of the same file. So I've selected the file, and now I have to give it a name. Let's just call it new terrain. So as soon as I've given these two parameters, I can click on process. What process does is it uploads this data to the Drone Harmony cloud, and it starts preparing it for work in the Drone Harmony web application. So before the upload can succeed, we start seeing some metadata about the file that we need to, in some cases, complete. So in this case, we see that the coordinate system of the GeoTIFF file has been identified in the metadata, the no data value as well, but we need to give basically the step size. How far apart are two consecutive points in the terrain data? In most cases, this data will be written in the file. As of the next version of Drone Harmony, these data will not be needed to be given. So this is something that is kind of a simplification that we're rolling out in the next couple of days. Basically, these two last parameters you will not need to give anymore. So this will be computed automatically for you, even if the metadata does not exist in the file. So here I input the values that are relevant for this particular file, and I click on process. So at this moment, the data has been uploaded to the cloud and the processing has started. Now, I don't really need to wait for the processing to end. I can close this window, and as soon as the processing will be over, I will see in the load terrain menu that this file is ready to be loaded. So let's look at this. So if I go to load terrain, I see my new terrain has already appeared here. However, it's still computing. So as soon as the computation will be over, I will have here a status, whether it's a success or a fail. It will be success for any non-corrupt GeoTIFF file that you will upload, and then I'll be able to load it to my scene. Okay, so let's close it. So perhaps now it has already been, no, it's still computing. So this is kind of the simplest way that you can add terrain to your scene. There are some limits to how large the files are and how many files you can load. You can visit our website. We have all the information on the website for this. And at this moment, I would probably like to make a small break. And I would like to do a small poll. And this is an anonymous poll, but would be very grateful if you answer this poll. Let me just start the poll. I've launched the poll now. Okay, another 10 seconds, and then we'll finish this poll and move on. Okay, thank you very much for your answers. This is very interesting. We will make another poll towards the end of the webinar, specifically about terrain and about how you are using terrain at the moment. So we really appreciate your answers. This is very useful for us. So let's go over again to the load terrain menu. And now we see that this new terrain that we've uploaded just a minute ago has now successfully processed, and we can load this into our state. And here it is. It's in fact the same data file as from before. Okay, so we've touched upon the following parts of the workflow. We discussed how to create a mission once we already have a mission. We discussed how to load the terrain file. I remind you, to load the terrain file, you just need a GeoTIFF file, a terrain file in GeoTIFF format, and you can do it through the terrain storage tab here in the menu. And the last thing that I want to touch upon is what can we do if we don't have terrain data, but we still want to perform terrain of our flights. So in Drone Harmony Web, you now have the option to access global data source of terrain data at a 12-meter resolution, which is the source of the data is Airbus. It's called World DEM, and you have the tools within Drone Harmony Web to import this data without basically through the web application, without needing to download a file somewhere. So let me show you this workflow. So let's again clear the state, and let's find some interesting place where we would like to, interesting place in the world we would like to load terrain data. So where I will go is I'll go to a very nice large open pit mine. very large open pit mine. And let's say that we are the mining company of this particular site, and we would like to perform terrain-aware flights, but we don't currently have terrain data to enable us to perform a terrain-aware flight here. What can we do? So in this case, there is this option of import terrain from Airbus, which is available currently to all our, let's say, professional users in Drone Harmony. So I can click on it, import terrain Airbus. And the first message that I'm told is basically how much quota do I still have for importing terrain, and it basically explains to me what I'm going to do. So I'll just press and continue. As soon as I press and continue, I am prompted with this tool. This tool is essentially kind of like a polygon tool. It's a selection tool for what area of the map do I want to get terrain. So I have several options. I can move this tool around. So this rectangle can be moved around. And I can also stretch and shrink this rectangle. So let's stretch it a little bit. And you see that the shape is always a rectangle just because of how this API and integration works. But the extent of it can be changed. So there is a minimum size that you can load. So if I make it too small or too narrow, I get a message telling me exactly what's the problem. So less than 1 square kilometer is too little. And I can also stretch it to be too big. So there are various different kind of messages that you get to decide if this particular import is possible. So let's just load the center of the mine here and see how this works. So I will now center it here, bang in the middle. And I see that the current selected area has size 1.8 kilometers. I can make it even a bit smaller, don't need such a big area. 1.3 kilometers. And my available quota is 56.6 kilometers. So I'm well within, so I can continue. As soon as I press on continue, I can give a name to this terrain file, just like I gave a name to the file that I uploaded before. So let's call it new open pit mine data. And I press continue. And then I get a message from the Drone Harmony application telling me the terrain import finished. And I can use load terrain, the same place where we loaded our terrain that came from files, the same place will host the terrains that we've used the Airbus integration to load. So I can close this message and I can go over here now to load terrain, open pit mine. This is the file that we've just created. Load this data. And you see that as before, the same kind of gray polygon now appears as an overlay, and I can start planning terrain-aware flights for this region. So let's switch over 3D DEM, and we can start seeing how this data looks like. So this is the data underneath. So you see that I didn't need to load any file. I didn't need to have any file. I could go to anywhere in the world and I could load this data because it's a global data source. So the one thing to remember is its accuracy. So the accuracy of this data is 12 meters, which means every 12 meters in every direction you have one sample, and the accuracy of the date of each sample is within a few meters. So if you're planning flights at, let's say, 50 feet or let's say 20 meters or above the ground, this data will probably be sufficiently accurate for you. If you're planning very, very low flights, this might be insufficiently accurate. So this will depend on your particular use case. But this is a global source, and you can use this source to perform terrain-aware flights. So this is the second way of working with, of including terrain into the application. Now, I want to discuss a third way, which is kind of an extended version of the file import version. And that's if you're a very big enterprise and you're interested in having this workflow for your big enterprise, and your big enterprise is performing flights in very many different areas, and you want all of this terrain data to be available for you in Drone Harmony Web, and not to ever need to load and move files around, then you can contact us. And for our enterprise customers, we're basically enabling the hosting of larger volumes of terrain. And then basically your colleagues, your users will never need to worry about loading terrain. In your user accounts, all the terrain that you own will always just be available. Just like I showed you before with the first example in Switzerland. I could browse around to anywhere in Switzerland. I always had data there. So this is just something to mention. Okay. Now, before I conclude the webinar, what I'd like to show you is just a few more use cases, a few more missions that you can plan for terrain-aware flights, and to mention kind of what use cases can there be useful for. So let me switch back over here to 2D map, and let's delete this area. So one use case that we've already seen is surveying and mapping. Obviously, you can map areas with complex terrain by using kind of the top-down grid missions. But what if you'd like to inspect linear infrastructure in complex terrain? Let's say you have a pipeline or a transmission grid component, something like transmission cables, or you have a road or vegetation, something that you need to inspect, which has linear form, and you would like to do this using the terrain-aware features of Drone Harmony. So let me just demonstrate to you how you could do something like this. So one thing that you can always do is, of course, outline areas yourself on the map. But what I'll do now is I'll import a KML file, which represents a road. And then I'll show you how I can use terrain-aware flights in order to inspect that particular road. So I go here, back to the menu. And instead of terrain storage, I will now first load a model of the road, which is a KML or KMZ file. So import data, import areas. The same kind of import wizard appears, so I can browse for a file. So let's browse for a file here. And in this case, I'll go to my downloads, and I have here this file, Mountain Road KMZ. So let's load this file. The file has been loaded, so I can process it and make it available in the state. Process. And it's telling me that there is like one line element in this file, and I would like to add this particular line element to my scene. I get a message that the addition of the line was successful, and I can close this message. So you see that we have this curvy looking road here. And by the looks of it, you also notice that this is quite a hilly area. So this happens to be in Switzerland, where I do have terrain information everywhere, as I've told you before, because we have prepared it kind of in the back end. So let's take immediately a look in 3D DEM how this looks like. So I switch over to 3D DEM, and very quickly the terrain tiles are being populated for me. So here I see that this is a very, very nice mountain road here in Switzerland. So let's perform an inspection mission for this particular road. Let's close the menu over here. So I switch over to 2D map. Let's try now to perform a terrain-aware linear scan. So I switch over to the terrain tab and go down to linear here. I choose terrain line here. And the rest of the workflow is very similar. I choose a start location. Now let's choose the end location to be on the other side of it. And I press to continue. So as soon as I press to continue, you see that I have the good old familiar double view, where on the left I have my parameters that I can adjust for this particular mission. And on the right, I have a visualization of how this mission actually looks like with respect to my terrain data. So as usual, I can adjust parameters. I can change the overlaps here. I can, depending on the type of mission that I'm planning to do, is it a mapping kind of mission, or is it just kind of an inspection mission? Will I fly this in a video capture mode or not? All of these questions, of course, factor into deciding what parameters, but in the end, we have kind of a visual of the mission here, and we have all the flexibility. So I can save this mission, and I can give it a name, maybe call it road scan, save. And the mission stays in my state. And I can browse it, I can look at it, and I can, of course, switch back to any of the other familiar views, either 2D or 3D, to take a look. So this is another use case. What else can be done with terrain-aware flights? So there's quite a few options. So you have mapping type options. You have linear inspection type options like the one that I've shown you now. And you have also perimeter type missions, which basically scan the perimeter of an area. This is just to show you real quick. This is here in terrain under perimeter. So you have, if you're familiar with perimeter type missions in Drone Harmony, those work exactly the same, except that they're terrain aware. They consider the terrain that's underneath the mission. So you can, for example, perform kind of surveys of the boundary of a region. If it's in a mountainous area, you can inspect the sides of a hill or of even a house if your terrain represents a house. So those are other options that you have. So this is kind of touching upon a few of the use cases that we have, and Drone Harmony is really working hard on more use cases. In particular, in the case of linear infrastructure, we're working on more advanced versions of these missions that will enable you to in a much easier way address even more complex use cases at ease. So stay tuned to kind of updates in this regard. So to conclude this part of the webinar, what I want is to make another really quick poll. I'm hoping that most of you here are interested in terrain-aware flight planning. So we prepared a very short poll that we'll also publish the results of to you right now about what use cases do you have for terrain. So let me just quickly release this poll. And I will give you another 30-40 seconds to answer this. This poll too is, of course, anonymous. Okay, thank you very much. We have a very nice reply rate. So I'll give it another 10 seconds to let some of the users that might still be trying to fill in the poll. Okay, so I'll end the poll here and I will share the results with everybody. So very nice split here between people that are using their own terrain data. So some of the questions were, what kind of data do you have? Do you have your own custom data? Or do you use publicly available data? Or you currently don't use terrain data at all? So there's kind of a 50-50 split between people who are using public and currently available and custom data. And in terms of the use cases, it's also very interesting. We have quite a few surveying and mapping use cases, but also linear infrastructure and agriculture are prominent. So thank you very much for this very valuable information as well. Okay, so so here I would like to basically start concluding my presentation. Before I conclude, I want to touch upon some of the kind of details about flight execution. So of course, we're planning these missions to be able to execute them in the field. So one thing that you might want to know currently is when you create such a mission in Drone Harmony Web, in Drone Harmony Web, you have access to the cloud and you're able to visualize the terrain and the missions. In the Drone Harmony mobile application, you have still just the 2D and the 3D views. So basically, the terrain missions, you will see their 3D shape, but you will not be able currently to see the terrain. So don't be alarmed if you're out there in the field and you don't see the terrain. The missions are exactly as you planned them in the web application. So that's something that we're working on. We're planning to add in the future also the terrain view to the mobile application. But in the mobile application, you have sometimes you don't have sometimes internet connection to stream data down, or you have lower bandwidth. So it's much easier to have bigger volumes of data to work with in the Drone Harmony web application. That's why we designed it here. Okay, so going over my notes for myself here real quick, checking that I have said everything I wanted. It seems so. So at this stage, I would like to basically open the Q&A session that we will maybe go for 10-15 minutes answering some of the questions that you have. Pardon me? And then we will conclude. So I will just real quick load this information for me here. Okay, so thank you for asking the questions. I'll be my colleagues here have helped me putting them on the screen so that everybody sees them clearly and I can read them out loud. So what accuracy can I get when using drone harmony? Is 2 centimeters possible? So, so the quick answer is yes, it is possible. And the thing is, you know, the accuracy of the map that you obtain from performing terrain-aware flight really depends on the drone that you're using, the altitude at which you're flying, and perhaps things like the lighting condition and so on and so forth. So 2 centimeters resolution is very, very, very much possible. One thing to bear in mind, you really want to perform a flight at an altitude that kind of relates to the accuracy of your terrain data. If your accuracy of terrain data is very, very high, like in the example I showed you in Arizona, where we had, you know, every square foot had 2 or 3 points of data in it, then you can fly really low, you can obtain imagery at very, very, very high accuracy, and you'll have a safe flight because you know that you've mapped the terrain to very, very high accuracy, so there's no risks involved in flying at low altitude. However, if you're using something which is at a much higher, at a much lower resolution, perhaps 30 meters resolution, which would be something like, you know, your public free available data, maybe from Google or something like that. If you have something like that, then flying very low is very dangerous with such data because the accuracy doesn't guarantee that you will not collide with the environment, with the terrain. So the only thing to bear in mind is that you need to adjust kind of the accuracy of the altitude of your flight to the level of accuracy of your terrain data. But something like let's say 12-meter grid, that is the Airbus integration that we have that you can now use globally through the Drone Harmony web. This will allow you to fly easily at something like 60 to 90 feet above the ground, should allow you to fly at this altitude. And unless there are obstructions that are not represented by the terrain, something like poles or buildings, then you should have a safe flight. And at this altitude with a reasonable camera, you should be able to achieve a 2 centimeter resolution for your map. But of course, it all depends on the sensor, on the payload that you're flying. If you're flying something like a LiDAR sensor, again, the same kind of answer applies. You will want to adjust, of course, the quality of the terrain you're using to the altitude that you're planning to fly above the terrain. But Drone Harmony enables you basically to import terrain at any resolution, at any accuracy, and plan flights for this particular accuracy. So that's kind of the quick answer to this question. So let me switch over to the next question. After data acquisition, can I verify my data with image processing, 3D modeling software like Agisoft, Pix4D, etc.? So yes, absolutely. So when you acquire data, this data is available for you to kind of run it through any pipeline that you'd like. It can be 3D modeling type pipeline, which would create a point cloud that you can afterwards also triangulate, make a mesh of. You can compare this data to the terrain data that you flew the mission with. So absolutely, this is a very, very common workflow. And Drone Harmony, in terms of compatibility, Drone Harmony is really very broadly compatible. There's no kind of tight marriage between Drone Harmony and one type of, let's say, 3D modeling software like a Metashape from Agisoft or Pix4D or a Bentley. we just make sure that our flight planning tools are sufficiently flexible and sufficiently powerful to enable you to achieve the resolution that you want, and taking care of all of the, let's say, flight parameters and flight characteristics like overlaps, resolution, and so on. So it's absolutely possible. And in fact, this is a very common type of workflow. Okay. 3 more questions. So there are some more questions in the chat, I'm informed. Okay. Is this tool readily available for us working in developing countries in Africa? So Drone Harmony is available globally. You're able to use Drone Harmony everywhere in the world. You can basically navigate to our website or directly to our web application and start using it, create your account and start working with it. In terms of the availability of the data that I showed you, the Airbus terrain data, this is also globally available. So if you're interested in performing terrain-aware flights and you don't have your own data, you can use our integration to perform such flights in Africa or anywhere in the world, in fact. So I'll read the next question. So in the future, is there an expectation to support BVLOS capable systems, such as live detect and avoid flight path changes for long linear infrastructure work? This is really an excellent question. So in terms of BVLOS, so currently with Drone Harmony, you can plan very large missions, with missions that would definitely correspond to a BVLOS type flight. The way that we intend to assist BVLOS flights in the future is to give you various options of partitioning missions into smaller chunks that into the sizes that you're comfortable with. So depending on whether you have BVLOS permission or are comfortable with BVLOS, it can be longer. If not, it can be shorter. So for something like a linear infrastructure mission, this could be a feature that breaks your mission into parts that are either all BVLOS with respect to, different starting and landing locations, or they can be already very long flights, but which take into account, let's say, the radio radius of the RC radius of your drone. So in this sense, yes. Now, another aspect of this question is, I guess, integration with other drone platforms. And yes, so Drone Harmony has on its roadmap to support other drones in the future. So at the moment, just kind of a segue into another topic, Drone Harmony mobile application is able to fly almost any professional DJI drone, and a lot of the prosumer drones as well. In the future, we intend to support other drone platforms as well. So we're working on such integrations already. And a lot of the, let's say, drone hardware market is currently moving towards drones that have a lot of sense and avoid capabilities. So in particular, if you're flying currently a DJI drone, which has obstacle avoidance in it, Drone Harmony doesn't tamper with the obstacle avoidance setting that you've set for your drone. So it will be obstacle avoiding if you kept the setting on, even in automated flight execution. In the future, when kind of drone platforms that are more akin to performing linear infrastructure at very large ranges, when such platforms will become available and kind of BVLOS becomes more prominent, then definitely more such features will come. But already now, Drone Harmony is supporting BVLOS flight in the sense that you can plan for BVLOS and you get the situational awareness from kind of the visual 3D interface and the obstacle avoidance algorithms that we've built in the planning phase, basically in the phase of avoiding the scene objects or the terrain in the case of today's talk. So the next question that I see here is, what data year does Airbus have? This is a good question. I don't have the answer right now, but I think that my colleague has just answered it. So the collection has started in 2011 and completed mid-2015. So this is kind of the data collection period. that is for this the world DEM data that's currently integrated into Drone Harmony. It would be, I'm not sure if there is some sort of kind of rolling update of this data that is happening all the time, but this is something that we can try to find out as well. Let's see if there are other open questions right now.
In the chat.
In the chat. Let's switch over to the chat. Thank you.
Make yourself full screen or show the chat.
Mm-hmm. Okay. So let me just quickly move here to the chat.
So I can also tell you.
Yes, please.
So is it possible to abort the mission in between and continue?
Yes. So the question is it possible to abort the mission in the middle of the flight execution and or continue? So in terms of the safety aspect, there is always an option to abort the mission by switching, let's say in the case of flying the DJI drone, which is the currently integrated platform, there is an option to abort the mission at any time by switching modes on the remote controller. We have actually a couple of webinars that go and videos that go in depth into actually flight execution. We very much recommend the viewers here to also take a look at before executing flights, or if they're interested in going into more depth. But there's definitely an option to abort the flight in the middle. The effect of switching the mode on the remote controller will be that the drone remains hovering in the air, and the remote controller gains manual control of the drone. So this is definitely an important option. There's also an option to pause the execution of the mission by tapping on the pause button in the flight execution window. This option allows you to also continue the mission. So let's say you're interested in looking at one of the pictures that was collected through the mobile application. You can pause the drone. The drone will hover in its current position, and you can perform some actions. Then you can press and continue. The drone will just continue. So this is another option. And in terms of long flights, in case you need, let's say, more than one battery to perform a flight, so there's definitely the option of continuing a mission from where the previous flight execution has been interrupted. So this is an option that is available in the launch dialog. In one of the tabs where the 3D view is shown, you have the option to resume a mission that has been interrupted before from in-flight execution. So this is another option that you have.
Next question is minimum and maximum altitude for terrain missions generally. What are the limits?
Yes. So the question is, what are kind of limits for minimum and maximum altitude of terrain-aware missions? So from the practical perspective, we've implemented some limits in order to avoid having, let's say, dangerous flights. So there are some hard-coded limits depending on the mission type. It can vary between a few meters and, let's say, 20 meters depending on the mission type. In terms of what is a safe altitude, minimum, maximum altitude to fly above terrain. So this is basically, again, depending on the quality of terrain data that you have. The rule of thumb is if your terrain has a certain accuracy, let's say you're certain that its accuracy is 1 meter. So at any point, the drone is, let's say at any point in the terrain, the terrain's height is within 1 meter of the real height, then you can fly very low. You can fly 4 or 5 meters above the terrain without a problem. If you're less certain about it, let's say if you have some global source, 30-meter grid type source, then definitely flying below 30 meters is not recommended, because it can be that the terrain is not accurate enough to account for such a deviation. In terms of maximum height, there are some limits to that too. This is of course, also limited by the regulations in your country. Drone Harmony will allow you to plan for a certain maximum altitude, which I think is 500 meters above the terrain. But it's very important to know basically the rules and regulations and the area in which you're flying to account for potential, let's say, airspace restrictions and things like this, and permits.
Let me try to share my screen to show you the next questions.
Mm-hmm.
Can you see?
Yeah. Okay. For data security concerns, is there a custom app available that can run completely offline, supporting documents for requests for information and qualifications by client? So in terms of running completely offline, so I understand here that the main concern is, so there are kind of two concerns. One is the availability of certain, let's say, classified data on a cloud. And there's also the question of offline. Offline meaning, for me, not connected to the internet. What can you do in the field in terms of not connected to the internet? So, so the Drone Harmony platform stores information in the Drone Harmony cloud. So you have the option to turn off what's called synchronization. Synchronization is the action of taking states that you generate either in the mobile or in the web application and loading them into the cloud, which are then available for download for you in the other. So you can turn on and off web synchronization if you want. We do recommend to have web synchronization on because it facilitates the collaboration between different parties in the organization. Now, in terms of, let's say, larger organizations that might have very sensitive asset information, it's possible to deploy the entire Drone Harmony system on servers that are belonging to the customer. This is something that we are able to do. So in such cases, it's very possible to start a conversation with us in this regard. This is kind of an enterprise feature. In terms of online operations, I'll just touch upon offline operations. You're able to fly all the missions that you have on your mobile device completely offline. The reasons why you might need to have internet connection is to either synchronize missions from the cloud. So let's say you've planned in the web and you now would like to fly these missions in the with the mobile application. So you at some point need your mobile application to be connected to the internet to download these missions from the cloud. So that's one thing. And another thing, you might want to have maps. Maps are currently kind of loaded through the internet connection, but there are ways of kind of preload. So from our experience, if you preload the maps in the office where you have internet connection and you go out to the field, then these maps remain cached. However, Drone Harmony currently doesn't physically cache, let's say, the Google Maps. In the future, we will enable kind of caching of missions through integrations of other map providers. So those are really the two things you might need internet connection for in the field. To execute flights, to see the states that you have on a mobile device, you don't really need internet connection. Okay, so in the interest of time, I think we'll answer one more question as the hour is almost past. So have you foreseen the possibilities of doing building inspection survey from high resolution LiDAR DSM? So the answer is definitely yes. If you have very, very accurate point cloud information that comes from some sort of LiDAR source, you can import this just as any other source into the Drone Harmony application. The missions that are currently available in Drone Harmony to use with terrain data, most of them are intended for inspection of things like of areas or linear infrastructure. Some of the missions, like the perimeter missions that I've just mentioned before, can be used for that as well. However, on our roadmap, we have much more, let's say, much more profound support of exactly this kind of use case that you're mentioning here. So thank you for this question. This is actually quite a nice question, and we're definitely foreseeing this kind of applications in the future.